Some mega marks to be had in this question, part A and B. We're given a sketch of a circle with center P11 labeled, tangent to the circle at 4, 3, then cuts the y-axis at point R. We're asked to find the area of the triangle PQR. Well, the first thing we can do is say that this is a right angle because it's where the tangent meets the normal or the radius, if you want to call it that. So we can try and find, well, we can find this length here and then this length here. That's what we were aiming for. Then we can use the half base times height. The bottom one's not too bad. We can use Pythagoras because when you have two coordinates, you can just find the horizontal distance between them and the vertical distance, and then do a squared plus b squared equals c squared, so square root. So the difference here, I'm going from 1 to 4 is 3 squared, and I'm going from 1 to 3 up, so 3 squared plus 2 squared, square rooted is going to give root 13. Okay, we'll just put that to one side for the moment. To get the other length is a little bit trickier. We're going to need to find the equation of this tangent, I think. So we need to work out the gradient of PQ and then take the negative reciprocal because they are perpendicular lines, these two. So let's say m, the gradient of PQ, is going to be y2 minus y1. So we'll do 3 minus 1 over x2 minus x1, 4 minus 1, which gives us 2 over 3. Therefore, the gradient of QR is going to be minus 3 over 2, that negative reciprocal. I know that it goes through 4, 3, so I can substitute that in. You can either use y equals mx plus c, or y minus y1 is mx minus x1. I always use this one. So y minus 3, we've got 1 point in the gradient, that's all we need, is minus 3 over 2 x minus 4. In fact, I don't need the whole equation of the tangent. I just need to know what happens when x is 0. So when x equals 0, y minus 3 is going to equal minus 3 over 2 times minus 4. So that is going to become 6, I think, plus 3, y is going to be 9. And that's my r coordinate then, 0, 9. We're very, very close now because we can use Pythagoras now on RQ in the same sort of way. I'm going from 0 to 4, so I'm going along 4, and I'm going 9 to 3 or 3 to 9. It doesn't matter. I'm going a distance of 6 in the y direction, so it's 4 squared plus 6 squared square rooted to give me that length there. That's 16 plus 36, actually root 52, which is in fact 4 times 13. So it's going to become 2 root 13. Your calculator will deal with that if you want. And we are basically there. So finally, the area is going to be a half times the base, which I'll call the base RQ, 2 root 13, times the height, which is root 13. It just happens to be, on its side, but we could turn it around so it looked like that. 2 root 13 and root 13 with the right angle here. The half and the 2 are going to cancel. The root 13 and the root 13 are going to multiply nicely to give the final answer of 13. Great. Let's move on to part B. So we've got a right angle triangle. We've got some sides given, but they're in terms of x. And we're told that cos squared theta is 1 over x. This looks pretty complicated, but let's just go with it, basically. What we're going to need to do is write down cos theta in terms of the sides. But what I need is the adjacent and the hypotenuse. Okay, so the first thing I'm going to do is find out that hypotenuse, capital H, which is going to be 2 root x squared plus root 3x minus 1 squared square root. And although this looks really awkward, the square roots are actually going to help because when we square root 3x minus 1, we just get 3x minus 1. Over here, I have to square the 2 and square the root x. I'm going to get 4x. So it's 4x plus 3x minus 1, which is root 7x minus 1. So that is my hypotenuse. Brilliant. Therefore, cos theta is going to be root 3x minus 1 over root 7x minus 1, which means that cos squared theta, I can just get rid of those square roots because if I'm squaring it, I just can square the top and square the bottom. It's the same thing. So actually, it's helped us out in the long run having those square roots because we don't end up with squared things. We just end up with 3x minus 1 over 7x minus 1. And don't forget that is then equal to 1 over x. And it's all about this at this point. Okay, the cos is gone. We're now trying to find the value of x. We've just got this equation to solve. So I can cross multiply. I'm going to get x times 3x minus 1 is 1 times 7x minus 1, and basically times in both sides by x and both sides by 7x minus 1. They just cancel out to leave us this. Okay, we got ourselves a quadratic. 3x squared minus x is 7x minus 1. So 3x squared minus 8x plus 1 is equal to 0. You could try and factorize this. It'd be tempting. Actually, it doesn't factorize. So we're going to need to use a quadratic formula. Now, I would be tempted to just put it straight in my calculator, but in the official mark scheme, they kind of expect, or they at least give marks for working. So what I would do, and we might be running out of time in this kind of situation, is let's definitely still put it in our calculator to get the answers. And if we've got time, we'll fill in the work in. Let's not stress about that though. So 3 minus 8 and 1. Now what does it say? Does it say to find the value of x? Okay, so I'll give the exact answers first. So x is 4 plus root 13 over 3. And before I get the second one, let's just write it. So it's going to be 2.54. Or 4 minus root 13 over 3, which is 0.131. Now, the only thing we need to do, aside from showing a bit more working if we've got time, is just to check that they are valid, because just because it solves that quadratic, it might not solve the original equation. There's lots that we've done along the way. In fact, we've squared at some point. So you can square a negative and make it positive, and it might not solve your original equation. And if you put the 0.131 back into here, we'd actually get a negative, because 3 times 0.1 something is going to be about 0.3. And then we're minusing 1. So I'm going to reject this one, in fact. Reject, since 1, what was it again? 3x. 3 times 0.131 minus 1 will be less than 0. Just a little explanation, I think. And so really these two, well, this is our answer. I've left it exact, and I've rounded it to 3 significant figures. Okay, I would then move on, but if we had time, this is when we could just say x is going to be, as long as we show enough working to be fair, you can still use your calculator solver. So x is going to be minus b, which is 8, plus or minus b squared, minus 4ac, all square rooted, over 2a, which is 6, and then we should get these two solutions. Let's just show that we do. So fraction 8, we'll do the plus 1 first. You have to put it in a bracket. Don't forget that. Actually, when you square it, it just becomes positive. So you can even, if you want to speed run it, just ignore the negative. Minus 4 times 3 times 1, that's just 12 over 6. And we get that same solution. And if you change it to a minus. So just, sorry, don't do that. I'd use the negative sign instead of the minus sign. I didn't like it, but then we get the same thing there. Okay, just a little technical bit at the end, just exam technique, I think, for how to deal with this sort of question. But the main bit was all about this. So yeah, brilliant. Well done.